I told you that ignoring a standard, like, $100 12-volt battery could trigger a complete catastrophic meltdown inside your advanced electric vehicle?
Yeah, and leave you with a massive €4,000 repair bill.
Right. So today we are doing a really engaging, fast-paced deep dive into the hidden heartbeat of your EV, which is the power electronics.
Specifically, the DC-DC converter and the onboard charger.
Exactly. We're looking at some technical maintenance guides and specialized market case studies to figure out why these modules are basically an EV's second most expensive financial vulnerability.
Especially right when a car hits that dreaded 4 to 5 year mark.
Okay, let's unpack this. That 4 to 5 year mark is what the industry calls the critical failure window.
Right.
But to understand why these parts suddenly die the second they exit warranty, we kind of have to look at what the DC converter actually does.
Well, looking at the schematics, its main job is stepping down the massive 800-volt power from the main traction battery.
Down to a standard 12 volt, so things like the radio, the lights, and the computers can actually work.
Exactly. I mean, think of it like trying to fill a tiny water balloon using a high-pressure fire hose.
Oh, wow, that is a wild visual.
Right. So the converter has to act as a heavy-duty valve, just absorbing all that intense 800-volt pressure so the 12-volt systems don't just explode.
And acting as that pressure valve means absorbing massive amounts of friction, which translates into intense heat.
Yeah, a ton of heat. Over 4 or 5 years, that constant heating up and cooling down creates what we call thermal fatigue.
So the parts are physically wearing down.
Exactly. The microscopic solder joints connecting the internal power transistors, they literally expand and contract until they crack.
That makes total sense for the physical wear and tear. But looking through these case studies, the failures don't really look identical across the board, do they?
No, not at all. Different brands seem to struggle with this thermal stress in their own unique ways.
Like Hyundai and Kia's eGMP platform, right? The Ioniq 5.
Yeah, they've dealt with massive recalls because sudden current peaks were just physically damaging the integrated charging control unit.
And then you have Renault Zoe. It uses that chameleon system, which is actually quite clever.
It is. It uses the motor windings themselves for charging, but doing that routes immense thermal stress right back into the electronics.
Even early, like pre-2019 Teslas struggled with this, but for a totally different reason.
Right. Their liquid cooling lines were routed way too close to the high voltage pins.
So tiny amounts of moisture would get in.
Yeah, condensation would bridge the gap and just cause a short circuit.
And Stellantis vehicles on the eCMP platform from 2020 to 2023.
Oh, they were known to just completely stop accepting alternating current charges entirely.
Right, so the vulnerabilities take totally different forms. But what really caught my eye in these guides isn't the massive high-voltage systems failing on their own, it's the trigger.
The 12-volt accessory battery.
It's almost a tragic design flaw.
It really is. When your standard 12-volt battery gets old and starts degrading, it just can't hold a charge anymore.
Because of that, the DC converter never gets to go to sleep.
Yeah, it gets stuck in a 100% duty cycle.
Wait, meaning it is running at maximum output 24/7, basically trying to fill a bucket that has a giant hole in it.
Precisely. And it literally burns out its own internal
Well,
hardware.
power transistors, right. The MOSFETs.
Yes, just trying desperately to keep that dying battery alive.
Okay, wait, hold on. I have to push back on this.
Shortcut?
These vehicles are some of the most advanced computers on wheels ever built.
They are.
Shouldn't a highly advanced EV simply recognize the 12-volt battery is dead and shut off, rather than letting a cheap component melt its €4,000 internal hardware?
You would think so, but it's a very controversial engineering priority. The system is designed to prioritize keeping the low-voltage network alive at all costs.
Because that network controls the braking, the steering.
And the central safety computers, exactly.
Ah,
But the consequence of that safety choice is just devastating to your wallet. Dealerships will quote €1,500 to over €4,000 to replace the whole melted unit.
which is wild, considering a specialized technician could open it up and do a component-level repair for like €300 to €800.
Oh, easily. Just replacing the blown fuses or transistors.
So why aren't more independent mechanics doing that?
Well, software barriers. Manufacturers use this thing called component protection.
Meaning VIN coding.
Right. So an independent mechanic can physically install a cheap refurbished part, but the car's computer will just refuse to turn it on because the serial numbers don't match.
You literally need proprietary diagnostic tools just to get the car to accept the new module.
Exactly.
Wow. So what does this all actually mean for you, the EV driver listening right now?
First off, treat your 12-volt battery like milk. Change it every 3 to 4 years, even if it looks perfectly healthy.
And second, keep your vehicle's firmware updated.
Yes, manufacturers are pushing out over-the-air patches that optimize charging algorithms to prevent these exact hardware melting voltage spikes.
And finally, try to avoid heavy AC use or fast charging under extreme summer heat. Give that system a break.
Proactive thermal management and keeping your software clean really can save you thousands of euros.
Seriously. Well, this has been an incredibly eye-opening technical journey today. Thank you so much for tuning in and sharing your time with us.
Yeah, thanks for joining the deep dive.
But before you go, I'll leave you with this. If a simple over-the-air software patch can prevent a physical piece of metal and silicon from melting, will tomorrow's automotive mechanics essentially just be IT professionals debugging code? Think about that next time your spaceship needs a tune-up.